Okay. Any questions from last week? Now that you've had time to digest it and embrace networking, go on, join in. I should make this bigger. Oops, that's not what I wanted to do. Yeah, any questions from, I guess, what we're going to be talking about? So we're going to be talking about networking tools. Why is that not working? I'll make this real big for you guys. Just hopefully, once again, I try to make this practical because I would love for you all to become network researchers, but that's not going to happen. And so, because Roblox is great as well, and FPGAs are good too. And so so I want this to be practical. So I'm sure you'll run into networking at some point, right? I hope you do, but at least right now. And so
I had students who were running into problems with networking today. So
today, okay. Well, let's see if we can solve them. How do I raise it up? No, I want to be able to lean back. Okay. So let's see. Okay, so let's start. So first, I don't know if someone, I don't know all the tools in the world, right? So, if you call one out, then I might not know it, I might know it, I'm not sure. But I have a list of tools that I thought were useful as I kind of thought about this, all listed right here, and some helpful commands in case I forget them. But let's first start out with knowing about your computer, what your computer is capable of doing. So that's often done through ifconfig. So ifconfig, interface configuration, ifconfig. This is actually an old command. I'll show you the new command, but it works on Mac. This will all be on Mac, but it should port over to Linux as well. So Macs, for some reason, have tons of interfaces. So how this looks is, I don't want to point to the screen because you won't be able to see that necessarily. So it's listed by interface and a colon and then information about the interface. And so there's tons of interfaces on this computer, and that's just how Macs are. Let me SSH into a different computer and show you what it'll look like on there. A little bit more reasonable. Let's see. Are these the same size? Not yet. Okay, so this is on an Ubuntu machine, just some server off in the internet somewhere. You now know its IP address if you're observant. So ifconfig, a lot more reasonable there. Only 3 things. That's even maybe more than you would expect. So one you're always going to see on every computer is LO. That's the loopback. That's your local host. So that's just like itself, its address to itself. And so let's go through some of these things. I don't know a lot of these things, but I know some of them, and some of them aren't that important. So what I'll point out is you can tell the IP address. This is the IP address of the loopback. It's always 127.0.0.1. These ones are a little bit more interesting, right here and right here. It's got your subnet mask. We talked about that last week, but it's how you know what your subnet is. You essentially would take these 2 things and AND them together. Remember, it's just binary at the end of the day. You'd AND them together, and what is left over would be what your subnet is, and the other part of it would be your host part. It's got broadcast address. In this case, I have an IPv6. It's INET6. I have an IPv6 address as well, which is kind of cool if you're inclined to use that. The last thing I'll point out is that you have your MAC address. So remember, the IP address is at the network layer. And then your MAC address is at the link layer. So that's hard-coded. I probably shouldn't be showing you this because you could do some bad things now knowing it. But hopefully you don't know what those bad things are. And so I'm safe. I don't really care. This is a throwaway machine anyways. But this is like hard-coded to my computer. And so that's why it supports essentially my social security number. You can think of your IP address more like your address for your house. You move around sometimes, and so it identifies you, but not always. Sometimes it might be in a different place. Whereas your MAC address is your social security number. It's always yours. You should always have it. Any questions on this? So this is, so why, anyone's thought why I have two Ethernet ports and 2 IP addresses? Any thoughts? And you can maybe get indication by what the IP addresses are. Yeah.
So the 10, is that like the local network, like the BYU network, and the other one, the external, like the global network?
Close, yeah. So this is actually not on BYU campus. So, but that would have been a good guess, yeah. But yeah, you're right. This is a private address. You can tell it's a 10 dot, so that means it's a private address. Whereas this, you might not know this, but this is a public address. So someone can feel free to ping it or try to hack into it if you want to. So yeah, that's exactly it. Is that this is running on something, it's a VPS, a virtual private server. It's running on DigitalOcean. And so they have some infrastructure. They say, well, here's your external IP address, but they must have some internal networking as well. So you can hook up your machines. Not that important, but just in case we're interested, that's why it has multiple Ethernet interfaces. Yeah.
What if the LO doesn't show up when you run ifconfig on your computer? Does it not come up because I've had times when I've tried to, I don't know, it just hasn't been there.
Okay, I think it should always come up, but I'm sure you can configure your system in such a way it won't show up. It's all dictated actually from a file. And so if you don't have this file, then it's probably wouldn't show up. Network and the interfaces. This file tells you, so this is where it lists all the different interfaces. So if you didn't have that file, then it might not show up.
So like a loopback file.
Yeah, so the file is interfaces, then it says, okay, hey, set up this interface. So this is saying when your computer first boots up, it says, okay, I'm going to set up the loopback interface, so, the LO interface. And then here it's actually going to other files and getting all the other interfaces. Okay, so actually for Ubuntu, you have to install something. If you do ifconfig, it won't work. Say, hey, you need to download NetTools. So the proper command is IP address. I think I can get with just that, but I think I was going to do show. That's the new one. I'm an old man, so I don't learn new tricks. And so I just do ifconfig. But this is the new. Yeah. So that's good to know and worth exploring. Now you're all familiar with man, right? Like the command man to bring up the manual page. That's a really important thing to be able to do because it'll tell you all about how to use this tool. So if you ever are wondering, I don't know how to use this tool, then look at the man page and then go do a Google search once you don't understand the man page. It can be a little dense sometimes. I mean, usually it tells you if like, oh, wait, what's that one command? Okay, -H for human. Okay, great. If you need to look up something, but it's not always the easiest read. And so, sometimes it can be better just do a Google search, but it's good to know. Okay, so that's that. Any questions on that? Okay, I'm going to get back into my my main computer here. So I'm back on Mac. Ping, that's a very important command because it lets you check to see if computer is online and if you can connect to it. So ping google.com. So what this will do is it'll send out a special message, an ICMP message, if you're interested, every second and say, hey, are you there? You there? And it actually has, I really love ping. I use it a lot because it has a lot of benefits. So first it's checking to see is google.com, the server that google.com is connected, part of, is it running? So of course it's running. Another thing that kind of a side benefit is actually does a DNS lookup for you, tells you what the IP address is of google.com. In this case, it's that. So that's kind of helpful. So, and it also gives you statistics about how long it took to ping the network. So it took 20 milliseconds to send that message, round trip. That's actually quite slow. It's because I'm on Wi-Fi. You'd expect it to be much faster on an Ethernet connection. But this could give you actually information about your network and how well it's working. So if you sat here long enough, you can say, well, okay, it's pretty stable. I had 20. And so this is a way to diagnose issues sometimes. It's not always the best way, but it's a kind of quick, easy one-liner just to say, well, how good is my network? Is it, failing a lot? Sometimes you'll see where just pings just fail. It's just like they time out after a certain amount of time. This is very, you can kind of tell we're on Wi-Fi because all of a sudden it jumped up to 70, here milliseconds, from 21, but it's pretty stable for Wi-Fi, I would say. You can, of course, man ping. There's lots of various things you can do. My favorite is -A because it'll do look sound for you. Let's see that. Let's see how well it works over this. No, is it not going to work now? My sound up enough? Yep. Oh, there. I like that. I don't know. It seems, so it's doing a ping. Anyways, you can set the interval to be, it defaults to once a second. You can set the interval to be much faster than that. I'd say be a little careful with ping. I mean, if you send it at some server and you have it set to like 1 millisecond, people might get mad at you. You might cause a denial of service type of thing where you shut down. Probably not, but be careful about that. Some servers, I'd say, do block ping. That's a thing a computer can do, is to say, I don't want to respond to ping messages as a security benefit, or maybe not wanting to deal with overhead. I think mostly security. So that's something to be aware of. Just because you didn't get a ping back doesn't mean it isn't there. But if it's like a general computer, then you're pretty safe in saying, okay, well, ping is, ping it will tell you if it's working or not. All right, anyone want to see anything with ping other than that?
One thing that I think is interesting is the TTL there.
Yep.
That prints out as well. That's good.
Yeah, you're right. So here we can see google.com, that time is 40, but if I go to somewhere on campus, netlab.byu.edu, it's only 2 milliseconds. So it only just had to go through the campus network. We'll talk about that in a second, how to determine where it went.
Like the specific port thing, or is it just?
It's actually a layer below that, so it's not going to a port, it's going to a host. Yeah, it's at the network layer. That's a great question, though. Yeah, very good. So I would say ping is one of my wideliest used tools. It's so quick and it's easy to use, and you don't have to think about lots of options. Just like check to see if that computer is there. What's going on? Why can't I SSH? Well, let me first just ping it just to make sure it's there, and they can figure out stuff. Okay. So speaking of this DNS lookup, so does anyone remember what DNS does from last lecture? A lot of you weren't there, but yep, domain name resolution, good. So it takes a name, something like netlab.byu.edu or google.com. Those aren't valid things for the internet stack. We need actual hard numbers. We need IP addresses. That's how we really get things done. And so it'll take the name and map it to a IP address. And it did it for us there, which is great. And so that's one of the reasons why I like ping, but you can do it directly if you want to. So dig google.com. And this will essentially do a DNS lookup for you, send out a DNS request. Here's the server it sent it to. It's kind of interesting. It sent it to a local server on BYU network. So BYU has DNS servers. That's off the DNS. We can't get into that, but if you're interested, take my networking class. There's a whole hierarchy to DNS servers. So we're seeing here, it's actually kind of interesting. There's a question section. I don't know DNS, why they did this. So the question was like, what's google.com? The answer section is, this is what google.com is. Here's my IP address. You can get a lot more complex than that. Let's do one more. So this is not as useful as ping. It's more of like if you're worried about the name not matching the IP address, but often you're not dealing with names unless you're like setting up a web server. Then you might be concerned about that, or you own a host name. Do you have a question there?
Yes. So in this case, you sent a different IP address for Google. Is there a reason? How does it determine which IP address?
That is a good question. So are you referring to, sorry, this versus this?
Versus, well, because that's BYU, but when
Oh, yeah, sorry.
From Google, I believe
Yeah, so DNS, okay, that's a great question. DNS is a source of much trickery on the internet. It's really great for that kind of thing because it gives you a level of abstraction away from, so they'll actually want you to use the host name, because then what they can do is geographically look up where your request came from and then give you the right server that's close by. Or they can do geographic kind of lookup stuff. They can also do load balancing. I'm not sure which one they're doing here, but Google's got, google.com is not just one server sitting somewhere. It's thousands of servers sitting across the world. And so when you do that google.com lookup, it will say, okay, well, you're in China, so therefore I'm going to send you the servers close to China. Well, I guess Google doesn't work in China, but close by. If you're in Utah, it'll say, okay, look up that. And so DNS allows you to have that layer of abstraction, say, let's choose the right IP address for the right place. And so it'll change based on load or just whatever they feel like. So that's why you'll see it change correctly. So that's a really good point. So this might be the IP address for the load balancer, and then it actually divvies out. When you actually talk to the individual server, it might actually be a different computer. So there's a hierarchy there. Yes, that's a good. Yeah, that's a very good point. Which actually is what I was going to do right here. I just had to look at this text. So yeah, so DNS is actually a really important part of your whole ecosystem for your internet connection. We don't really talk about it much. You think, okay, well, how fast is my internet? 1 gigabit per second, great. But if you have to do a DNS lookup for every single request, then you're not limited by necessarily how much data you can send, but like the latency of that DNS server. So often you want to choose a DNS server that's close by, but also is good performing. And someone like Comcast doesn't really care much about their DNS servers. And so often people will say, I don't want to use my ISP's DNS server. And sometimes it is better to use them, but I want to use some other DNS server. So Google provides a DNS server, 8.8.8.8. Cloudflare also, I did ping. Cloudflare also provides one, and I think it's 1.1.1, and there's a bunch, open DNS. So a lot of companies have these. And so you can program your device or your network to use specific DNS servers. So let me bring up the right command. Okay, let's try that. At 8.8.8. So here we're telling dig to use a different, and I don't know why the syntax is like that. And here, sure enough, yeah, we use this server instead of our default one, which is on the campus. So you could figure out which one's faster for you. Well, I was going to say something else about that. Okay, to your question maybe before about ping, DNS runs on port 53, if you're interested in that, and it's application layer protocol. Yeah, any questions about that? Yeah, we're seeing the IP address change. Any questions about dig? Oh, there's one other one, nslookup. I don't know which one's preferred. I just know dig, and that's what I use, but nslookup provides the same benefit. A little bit different format, a little more concise, I'd say. I always just do dig though. That's just what I'm familiar with. So here we can see, I'm doing a local one, so we can see netlab.byu.edu is actually a C name, so it's just like an alias. It's like a shortcut for this URL, for this host name, and then this host name is actually this IP address. So you can have multiple layers, and that's all encompassed in the actual response to in your DNS request. There's a lot more to DNS. It's a complicated protocol, but that's the high level. So that's one thing. Like I said, I don't really use that much. I feel like DNS usually isn't an issue, but it's good to know when you do, think it's a DNS issue to be able to do that. I use it more when I'm like setting up a web server, and I need to know, okay, why is my netlab.byu.edu not working? Oh, it's because it pointed to the wrong server, or something like that. Okay, next one is traceroute. This is a really good tool. Let's see what I have here. Traceroute will go through and see all the routers that your network, that your packets have to go through to get to where they need to go. Google.com. And actually, I really feel like it's quite fancy how it does it. So here, I was working on my wired network when I was testing this out. This sometimes happens. So it's listing all the servers, but then sometimes it can get stuck in a loop, or they don't want you to know, it's not going to respond back to it. Okay, got through that. Hopefully eventually can get to actual server. What's doing, it's actually really cool, is IP packets have a time to live field in them. And so what it does, and if that field ever gets to 0, then you have to drop the packet, and every router that the IP address packet goes through, it decrements it by 1. So you set to 100, it goes through one router, it says, okay, now it's 99, and sends it on to the next one. And that's to prevent from routing loops, because there are ways to have, if you configure your network wrong, you can have routing loops that route forever. And so let's protect against that. Say, well, eventually this packet will die because it's just the time to live gets to 0. And so what traceroute does is it sends a very carefully crafted IP packet with a time to live of 1, and sends that out. And then I guess when you set it to 0, you're also supposed to send a response back, say, well, hey, it was set to 0 and an error happened. So it sets it to 1, it sends it out, gets the first hop, gets that response back, then sets it to 2, gets the second hop, and just keeps on playing that game forever until it finally gets to the destination. And I just think that's really clever of them to kind of come up with that idea of able to trace through a whole network of what are all the routers. So it's kind of crazy. Your data goes through so many different devices, routers, and to get to google.com. You can kind of actually start telling some interesting things about it. Like, okay, we're using Veracity Networks, apparently. That must be one of BYU's ISPs. I don't know if anyone heard of Veracity Networks. It's like fiber optic here in Orem, or in Provo and Orem. I guess it's Provo. And so you can kind of actually start seeing, if you want to, you can make sense of some of these things. Okay, I went through BYU. Let's do maybe a simpler example. Yeah, so that's pretty simple. So I went through some, and then got to some random computer here, some PC. It's hosted by Kadem, and that makes sense. It's et.bua.edu. And I got to here. So it will send these packets 3 times each, mostly, and then it gives you the, how long it took for each. Like that. I don't know why I only sent it once here. So it's a great way to kind of trace, to make sure, is it going through the path I expect it to go through? Yeah, I don't know. Once again, it's a nice kind of debugging tool. Like, why is my internet so slow? What's going on? But it's not something that, unless you're dealing with like core networking stuff. If you're dealing with like a small like home network or one hop network, usually don't do this, because there's just one hop. You're not really dealing with very many routes. But yeah.
If you were to ping a server in China, how many hops do you think on average that would be?
I don't know. I'm not sure.
China.
I mean, what's a server in China? I don't know. Well, I don't know what server in China, but that would be an interesting experiment to see. And sometimes it doesnnt work. I mean, I don't know, LDS.org. Let's see what that does. Sometimes maybe it would eventually do it, but I just get impatient. I just go, okay, Interesting. LDS.org is going through some BYU thing because it's got a .byu.edu. There you go. We learned something new.
I think LDS.org is actually hosted in the bottom of the Talmadge building.
There you go. Okay.
Really.
It's not always accurate. There's trickery, and once again, they don't have a router doesn't have to respond to this. It's supposed to, when the time to live of the packet gets down to 0, it's supposed to drop the packet and then send an error message back to the destination saying, hey, something went wrong. It doesn't have to do that. And so that's where you get into these kind of loops right here where no one's responding. It's just saying, I'm going to just keep trying until it finally works.
If you want to find something international, you just do google.de and you can find the German server for Google.
DE?
Yeah. I don't know if it's actually different or not, but like it works.
Okay. Cool. Yeah, so that's a helpful command to know about. Any questions on traceroute? Okay, ping, dig, and traceroute. I kind of consider them the same thing of just like tools to get outside yourself to like get your feelers out of testing what servers are out there, what's going on with the network. Now we're going to talk about other tools in terms of actually how to like download stuff, and this is helpful for various commands. So curl is a popular command. Anyone used curl before? You probably have used it by accident if you didn't even need to. Okay, APIs, yeah, that's good. Curl, let's see, let's be official here. Google.com. So what it does is it goes out to the internet. This is a tool to work with HTTP. So all the other things have been at lower layers. I mean, DNS is at application layer, but it's a different protocol. Ping is more at the network layer. This is application layer working with HTTP. So if you're not working with HTTP, then it's probably not useful. Though can also do like FTP and other various things. So it's actually a pretty good tool, but it's mostly used for HTTP. So what it did is it went out to google.com and downloaded the HTML for us. I'm always amazed by how ugly google.com is for such a simple and clean website, but there's a lot of JavaScript trickery going on here. We can set the verbose flag to see a little bit more what's going on. Let's go back up the top here. So we can see these arrows denote what we sent. So this is what we sent. First, we connected to google.com and we sent this message. In ASCII, we sent this message, and then this is the response we got back. So here's the HTTP header. So this is what your web browser is doing. Every time you click go, it's sending out this message to whatever server you told it to. And then you're getting this response back. The server just takes this part, says, oh, and ignores, doesn't ignore it, but it doesn't show it to you. It does logic with it. And then it puts this, it displays this, renders it into your web browser. So that's all happening behind the scenes. Okay, let's maybe do a little cleaner page, netlab.byu. Okay, so it's kind of interesting. What's happening here? I did my GET request. And you can do more than just GET request, but and it says it's a 301 permanently moved. That's kind of interesting. So it didn't work quite right. You can kind of see it's saying location. This is where you should have gone. So what's happening here is we went to it added for us kind of as a nice HTTP : // it added that protocol to it, saying, hey, you're talking HTTP, go ahead. So try to get netlab.byu.edu with HTTP. And I've set up NetLab to not work with plain HTTP. You have to use HTTPS, secure version. So that's how these things are resolved. As you go to HTTP, it'll say, hey, I moved, go to HTTPS instead. And web browsers will follow that for you. They'll say, okay, oh, it's moved. Let me go to this location instead. Curl is much simpler of a tool. It's not going to do anything for you really. And so it's just saying, hey, it's going to bring back the response. And so if I go to HTTPS, the secure version that's encrypted, then it'll get the actual website for you. So any questions on curl? Oh yeah, I'd say, often you're not holding up HTML with curl. Like that's, no one wants to look at this. That's kind of ugly. So you'll want to download stuff typically is what you'd want to do. You can, you'll want to download things. So like, what should we go to? I don't know what you just said, but let's just, I like Apple, let's do Apple. So I'm gonna copy this. Of course I could just download it right here, but I'm gonna copy this, I'm gonna curl it. Oh, I didn't click the image. Is this gonna give me an image? Oh, okay, good. Oh. Okay, copy image. Okay, let's try that. So what's gonna happen here? Good. So it said, hey, you're downloading a binary file. Are you sure you want me to paste this into your terminal? No, I don't want you to paste that. So, and so you can, there's lots of options with curl, you can do output. I'm not going to do that but I'll show you in a second. So curl can do binary stuff. I mean, you can send it to a file, but if you're going to be downloading stuff, I think the better tool than curl, but it really depends, is wget. That's another tool, wget, that is designed to download stuff for you. Hit that command. It will do essentially the same thing that curl's doing, and that to go out to the internet, will download it for you, and then it saves it to a file right here. So open this up. There, we got a magical file right here. So you can do this with a video. You can do this with the image. You can do all sorts of this. Is great for scripting things. To download a bunch of things for you that you want to automate. wget will take care of that for you.
I think curl is often as a curl library. There's probably one for Python. I know there was one for curl. I know there's one for C.
Yeah.
Like curl libraries allow you to do something curl in your code.
Yeah, that's true.
Use kind of a modified syntax a little bit.
Yep.
Really more custom library-based topic, it's just like a basic tool.
Yeah, curl is on most systems by default. wget not so much. So yeah, curl is kind of like the base thing. If you can have, if you got curl, you're good to go, kind of thing. So yeah, that's a really good point. My preferred tool is httpie, which is abbreviated to HTTP command line. This does a lot of the same things that this isn't gonna work. Okay, does a lot of the same things that curl does, but it's written in Python, so that's a pro, and it has a lot of niceties in it. So http netlab.byu.edu. Go up there, and so like one thing it's doing right away is it's highlighting things in nice colorful for you. So that's, if I'm going to do anything, I actually rarely use curl. I use HTTP, and it's got lots of nice features to kind of deal with JSON data. So if you're working with an API, then it's a great tool for that. And so let's just plug for that. You can see how it's, but very much the same kind of thing. Okay, any questions on those tools? It's just good to know about. I don't expect you to have learned it based on me just showing you. I just want you to know that it exists, and then you can go look up the Wikipedia article or the man page for it later. That's just good for you to know.
So just a quick potential clarification for my brain. So
Yeah.
curl is essentially just retrieving whatever is there, whereas wget is specifically for like downloading files and stuff from the internet.
Yeah. And curl, I mean, you definitely can download stuff on curl. So there's a way to do that. It's just, to me, it's a little
But it retrieves whatever's there, and then you have more configurations that you can do, like sending it to a file and things like that.
yeah. I mean, where I see this a lot, because I don't know, it's just off the top of my head where I see it done. So if you want to install this tool, they'll have this command for you right here. I probably shouldn't advocate for this. I'd run it, but this is a dangerous command to run because you don't know what's downloading, but I run it anyway. So here they're doing lots of trickery where they're actually getting this shell script from the internet. So we can go to it. It looks like this is the shell script. We can view it. They're downloading it using curl, and they're actually executing that shell script live, and so that's a really nice way to kind of, then you don't have to download anything, just with one command. So you'll see that often with curl, where it can like download something but then run it right away. And of course they have it with wget as well. And so you can do the same kind of thing with wget. Here, wget's designed to download. So you have to say, well, don't download it, actually output it to standard out and then run this command. So that's an example of where you'll see curl sometimes. But yeah, that's good clarification. Thank you. That's a good point. Yeah. I don't know. I mean, anyone disagree? I guess I'm pretty sure I've heard people say curl before. Sometimes in the computer world, you're so isolated. You just in your brain have this is how it's said, and then you actually don't ever hear anyone say it out loud. I'm like 99% sure it's curl. But anyone, you agree, right? I mean, I don't know. Dr. Mangelston, do you agree?
Yeah, I've always heard it as curl as well.
But you could be the trendsetter. This is a cool tool. See,
like GIF versus GIF arguments
Yes.
all over again.
yeah.
Maybe the original guy that made it wanted to use URL.
Yeah. And it's got all sorts of powerful things. And like you were saying, there's a lib associated with it. So that's what like C bindings for and Python bindings for it. So. Yes, use CURL. It's a great tool.
It's nice if you already know Perl, then like you call a library, you can use it in that program.
Yeah.
Then Python or C and Perl.
Okay. What time is it? I'm gonna skip over ARP. Anyone interested in ARP? What does ARP do? That's a good question. Ashley, you want to answer that? Oh, wait. ARP-A. ARP will. So Ashley, you tell us what you use it for, because you know. But what ARP is, it's essentially the DNS for layer 3 and 2. So DNS maps a human name for us humans to an IP address that we don't remember. What ARP does maps IP addresses to MAC addresses. So, but it's all done locally. So if I send an ARP request to say, hey, I know this IP address, what MAC address this is associated with, and then someone will respond and say, okay, this is it. So the ARP command line tool gives you an option to kind of see what's going on under there. So you can look at your table, you can send an ARP request, you can see, so here I sent this out, it's like, okay, here's this IP address, what's the MAC address associated with that? Okay, this is the MAC address associated with it. So someone's Galaxy S8, and I don't know how we figured this out, you know, this is his IP address and this is MAC address. So now I'm able to send Ethernet packet frames to it because now I know it's Ethernet address. What do you use it for, Ashton?
I hooked a Raspberry Pi to the BYU network and had a couple of devices I needed to like SSH into them. I didn't know what IP address was, so I just ARPed my little network that I was on and gave me a list of IP addresses, and I just went through them and went through them.
Yeah, so that's the way you kind of discover what's on your network. And I think there are better ways to do it, but you know, the tool that you know how to use is the best tool for the job. You know, yeah, it works. There are other reasons, and if you're trying to figure out, well, why is it not connecting to this one IP address, then you might want to say, well, you know, is ARP working? You know? So that's that. Okay. Then there's nmap. I would say nmap is a great tool. I just know the surface of it, but my caution to you is be careful. Nmap can get you in trouble.
Yeah.
I think I asked them to install it on a K machine, and they let us do it, but they said if there's any students doing bad stuff with nmap, we'll not install it on your computers anymore, because you can get it, you know, do stuff. It's of course has really good purposes for it, but you can do lots of bad things with it as well.
At least the version last year that I made one of the things I was working at,
Okay.
and I think I got away with it, but it could not be on the wall. I don't know.
Yeah. So this is like a Swiss Army knife for penetration testing, sniffing, discovery. Just kind of see out there. It's got a lot of cool tricks to it for how to discover what devices are on your network or what ports are open on a computer. And so it can be used for good things, to see what ports are open, to, you know, protect yourself or see what devices are on your network, but also can be used for bad things. I could say, well, let me examine all the computers in this room and, you know, see what ports are open. So I could say, oh, you got SSH open, I'm going to start trying to crack your password, or you got HTTP, I'm going to see if I can break into your HP server. So that's what it could be used for in a bad way. And it can generate a lot of traffic because it automates a lot of things for you. And so this is a tool you want to be careful with.
Yeah, a lot of networks will like, if they're trying to use it, that phone book for people doing a map and like block it and maybe even try.
Yes.
Especially at any probably.
So
So like, oh, this guy's doing this, and then they'll figure out who's doing it.
so
Maybe block them, I don't know. But
So let's run this. This is a Raspberry Pi that's sitting on my desk in my office. So I give myself permission to try to hack it. And so what it's going to do, just default, as I gave it an IP address, is it's going to go through, it's going to check the top 1,000 most likely ports used and tell me what ports are open on that computer. So first it checks me, and he essentially does a ping for me. He says, is this computer up and running? Yes, it's up and running. And then what ports are open on it? And so in this case, SSH is open on my Raspberry Pi. It tells you what port it's open. And so you can, what do they call it, fingering? You can like probe people and say, well, what ports do you have open? And then you can try to find vulnerabilities. But it's also great for other things too. So it is a tool you can use occasionally, you know, for legitimate purposes. Yeah, like I thought this was kind of a cool command. I had to look through this because I'm not super familiar with it. But this will essentially search the top 10 ports that are most commonly used and check what's open and what's closed. So in this case, I only have SSH open. All these other ones are closed. So where the trickery comes in is, and what's really cool, is it will do kind of dumb pings for you, just like a ping message, but sometimes people block ping. So it's like, oh, okay, well, ping's not going to work. It's not very reliable. So this is where nmap comes in and say, well, I'm going to be a little more tricky. I'm going to set up maybe a TCP connection with you. And I'm just for the purpose of discovering if you're there or not. And that's it. And they'll drop it right away. And so that's a lot harder to block because you need to be able to accept TCP messages. That's what HTTP is built on. So if you're HTTP server, you have to accept that because you don't know if it's a legitimate client or someone trying to probe you. And so you accept it, and then now I know you exist and what your IP address is, and that port's open. And so it has a lot of cool trickery of doing UDP, TCP SYN messages, TCP, it'll crap, I don't know, it's a lot of cool things. Where the power comes in is that you can actually do like whole subnets. You say, oh, like check all these computers for me at once. I mean, this command would take a long time, but it would go out and search all these computers, or you can do ranges, it's really kind of user friendly, like something like that. I'll search, 1 through 100 on this network. I mean, should we try it? I kind of want to try it, see what happens. Okay, I'm scared. I don't want to do any much. But it would be checking all those computers and seeing what ports are out there. And so that's where you start getting in trouble. Is you could generate a lot of traffic. And it's not very hard for a network administrator to see what's going on. So that's where they'd say, oh, I'm going to block this person's access now because they're obviously trying to find vulnerabilities in our system. So I encourage you to, if you're interested in this, don't do bad things, but go explore the page, and it's got lots of cool things you can do on it. Let's do man and that. Let's see. I just made a slight against man pages that they're hard to read. They are hard to read, but there's actually sometimes Easter eggs in it. And the person that wrote it, was from the 70s and had a bit of a sense of humor, computer sense of humor, right? Which is a little different than a normal sense of humor. And so you can find some little funny things in there that I can't remember. I think I showed you guys in the networking class, but there's various things in there. So yeah, it's worth reading and looking at. And here I'll show you like what you can do. Like, okay, I want to list this scan. I want to do a ping scan. I want to do a UDP scan. I want to do a TCP SYN connect scan, or I don't know, all sorts of cool things. I don't even know what is this, a zombie host, port probe. That looks cool. Idle scan. Let's try that. Yeah. So great tool. Use it, but be careful. Any questions on that? Okay. Okay, so that's kind of it for tools. For kind of diagnostic tools for just general networking. Now I'm going to get a little bit into, I guess I still got more, but one tool I want to show you real quick is Netcat. This is a tool I use if you're developing like some kind of web tool, or you want just essentially like, I want to be able to send data to something and just see what it's outputting, just like without any logic happening. Because sometimes if, let's say you're designing your own HTTP server or a client, it's like, well, I can send it to a server, but I'm not getting a response back. What's going on? Is my message malformed? Am I not setting up the TCP connection right? I mean, what's going on? Netcat is a great tool to kind of just give you raw hooks into what's going on. So it's arbitrary TCP and UDP connections and listens. So you can set up a quick server, a TCP server. Just do the -L for listen. So it's going to listen on a port you provide. I'm just choosing 8080. Do any port you want within reason. You can't do like private ports. You have to do SSH or sudo for that. So what I can do now is I can say, I can set up my own Netcat local host on port 8080. So I'm a client right here and I'm a server right here. And so now it's just saying like, oh, now you guys are connected. Great. What do you want to do? Hey, and it showed up there. So this could be computers across the world if you want to, and they all had, I chose local host because it's running on here. But if you were running this, I could get your IP address and then connect to you. And so now we have a TCP connection going on. We can send arbitrary data. I don't know, not that useful, but if you're debugging something, it's useful. Let's set this up. Let's do HTTP local host port 8080. So sure enough, I'm trying to do HTTP requests. That's what this tool does. And sure enough, that's what it received here. Now, notice how this tool is not getting a response back because Netcat's not programmed to do anything. It's waiting, HTTP's reading for a response back. We can do a test, see what happens there. Yeah, HTTP said, that's not valid HTTP. You're not speaking the right language here. That's a bad status line. So I'm just gonna, cancel. Let's try here. Let's run, I remember this /1.1. Was it 404? Bad. I don't think it actually matters. So I send that. Sure. Oh. There, so it got it back. So that was validate, HTTP, and then after this would be actual data. So here is some data. I have to close the connection. Okay. So sure, I wrote my own very poorly written HTTP response, but it accepted it as a HTTP response. So that's great. So that's that's the kind of thing. If you're debugging something, then this is a valuable tool. Whether to be a client on one end and type, you guys option to type in raw data, or be on a server and have the option to receive the raw data and respond with raw data. It's a good tool to that. You use this extensively in my networking class to debug stuff, right? I don't know, did you have to use it? I tell people to use it. I don't know if they actually do. Okay, who knows what students do. Okay, now, so let's say that, I guess Netcat was a little one-off thing. Now let's talk about one of my favorite things, because I feel like every time I do this, I learn something new. Wireshark is what I would call this tool, because it's the most popular tool, but the genesis of that is tcpdump, and sometimes you need to use that. So I'll show you that first. So what tcpdump is, I have to run this in sudo here, is it's going to listen to all my traffic that's going on in this computer. So it's a really fantastic tool for that. So, my computer is sending data back and forth to the internet all the time, right? Doing all sorts of, evil and malicious things. And so, but I don't have insight into that. I mean, I guess I could bring up my activity monitor, say, okay, what processes are using network here? And I could see, oh, well, Zoom is sending a lot of data. What's going on there? And, you could do stuff like that. That's one way to kind of do it, but you're not actually seeing what the actual packets are. And so tcpdump lets you do that. So here, whoa, got lots of data going on. So it's what it's doing. And why I don't suggest using tcpdump unless you know what you're doing is because it's not very intuitive to read. So we got Jared's iPhone. Is anyone Jared in here? It's sending data to this. We're now seeing the actual raw packets that are being sent out onto the network. It's not very helpful. And I mean, there's tcpdump is very powerful, so I'm not trying to discount it, but often what you'll want to use that's graphical is Wireshark. So I'll give you the same information here in a much easier to read situation. So here I have to bind it to a certain interface, right? Interfaces are like my Wi-Fi or my Ethernet, or, in this case of a Mac, I have a lot of things. These are various USB things that are, presenting themselves as interfaces. I'll point out, where are you, Loopback? Oh, let's see what's going on there, because Loopback, my local host, why am I sending data to myself? Let's find out why I'm sending data to myself. It's trying to show you a little line here, activity that's happening, this little micro graph thing. Okay, so we can start kind of seeing what's going on here. So let's stop it and let's stick through this. So it's showing you all the packets it captured up here, and then down here you can drill into the specifics of the protocol, and then down here is the raw data of it. And this is a fantastic tool because it has so many helpful things. So let's look at, here sending. What are we sending to myself? We can tell what port it is. You can actually look at, oh, this is what a TCP packet looks like. This is the payload of it. And it's got a source port and destination port and a sequence number and all sorts of stuff. And then here's the data. It's just 2 bytes long. That was it. All this data to send just 2 bytes of data. Kind of crazy. I don't know what this is actually, but my computer's sending data to myself for some reason. Here we can see multicast DNS. I'm not trying to look at this to see if there's anything interesting here. Yeah, so that's that. I mean, let's do something maybe a little more interesting. So let's go to my Wi-Fi interface. Now this will probably go crazy because I'm sending data over my Wi-Fi interface because I'm zooming. So we'll see a lot of Zoom traffic. And so this, this is where you can actually figure out what the truth is. Like I told you guys that UDP last week, that UDP is used a lot for multimedia type stuff because it's time sensitive. Well, look, we got lots of UDP traffic going on here. So hopefully this is Zoom traffic, and then I'm right. But you can see things like TCP connection going on here. You can see TLS connection going on here, and so it's a great tool to. I try to use other higher level tools first, but if you need to know what's going on in your network, then this is a tool. So for example, one way you might use is why can I not connect to the server? You can go in here and say, okay, look at the TCP connections, messages go back and forth and say, oh, it's because the server's not responding in the right way, or because TLS is not properly negotiating the certificates. There's a lot of power to this. Let me show you one thing. So one powerful thing is you can click on any TCP message and say, hey, I want to follow this TCP stream. So it'll take out all of, just filter out just to one TCP stream of data. And it shows you what the data is. So it must be encrypted in some way because we can't make sense of that. But then we'll go back here and we can see all this stuff. Yeah, sure enough, it's using TLS. But we can see all the data that's associated with this connection right here. So it's pretty cool what you can do. Let me just maybe something a little bit more scalable. Let me go back to my loop back here. Continue without saving. Sure. Let's run that. Okay. And let's sorry, that's so small, but you don't need to see it. Netcat local host 8080. Okay, I want to make sure. Right. Okay. Let's restart it just so we can hopefully get this right. Right when it happens. Okay. Oh, I'm already set. Okay. Test 2. Okay, great. And close the connection. Okay, let's see if we can find that here in this mess of stuff. Okay, where are you? We can, no. Darn it. Okay.
Was it logging when you?
Oh, was I not logging? I wasn't logging. Thank you. Okay. Where are you guys at? Come on. Dr. Mingles had to figure that out for me. Okay, let's do this again. Let's be a little more careful. Okay. Yes, logging right now. Oh, it's because the filter is turned on. That's why. That's why. Okay, let's do that again. Test 2. Close that out. Okay, let's turn off this, stop this, and then let's turn off this filter because I'm not the first TCP stream. Okay, so somewhere in here, okay, we probably saw fin, that's like closing, so let's follow that. TCP stream. Oh yeah, sure enough, look, it assembled our TCP messages of test and test 2. Great. So now we can start seeing all the messages that go into it. So it's kind of crazy. It said test and test 2, all these messages had to go back and forth. TCP is very verbose. You have to set up connection, you have to tear it down, you have to acknowledge everything. But you can kind of see in here, okay, we got a SYN packet, that's how you start up connection, then acknowledge that connection, and then it sent an ACK, and then it updated a window, and then it finally sent the data. You can see the data right here in the payload, it's test. So this packet contained the data, and then we acknowledged it, and then we sent back test 2, and then we acknowledged that, and then we closed the fin flag is to stop the connection and acknowledge that. Anyways, so you can kind of dig through this and start understanding what's going on. Oh, what are these flags, and what were they set to? Oh, that shouldn't have been that way. That's why what's going on. And I had to use this for like my networking class, for example. Students were having issues with their code, and there's weird behavior, and so I spent like a long time trying to diagnose some person's issue, and it was a really strange and cool confluence of issues. But I was using Wireshark to kind of figure out what's going on with this, because that's the ground truth of all the packets that are being sent out to the computer. Do anyone have a question on that? So of all the tools, I'd say, maybe it's the least useful to you because maybe you only use this if you're doing networking research, but I don't know, Dr. Mingleson, do you feel like any of your students will ever have to open up Wireshark?
Yeah, so I actually had a student last week who did.
Oh, good. Okay.
Yeah.
So there you go. So this is a tool.
Sending UDP data between different computers, and they weren't, one side wasn't receiving it, and we had to figure out what's going on.
Great.
It was actually being sent over. There were a network interface card had 2 IP addresses, and it was being sent over the wrong one.
Yeah, so that's a great way to figure it out, is using Wireshark. I will say there is a companion tool to Wireshark called tshark for Terminal Shark. You might ask why not just use tcpdump? That's a good question. It's because it's compliant with TCP Shark, so you can use the same filters, and whereas tcpdump is a little different. So I really like to use this tool for scripting stuff. If I want to set up kind of Wireshark in the background and have it parse through here, I can have it run tshark, and then I can grep things, or I can run filters in tshark. And so there's all sorts of cool things you can do once Wireshark is in the terminal to grab the right information.
So like the idea is basically like you figure out how to do something like what you're looking for using Wireshark, and then you can replicate it as a script.
Yeah.
using tshark.
Exactly. Yeah, that's exactly what I do. Is I go in Wireshark and say, well, hey, I'm actually really interested in making sure that this fin bit is set. So I look up. Actually tells you right at the bottom here is really small, that how to access that flag is tcpdump.flags.fin, and then I go into tshark and I set the corresponding filter. Say, okay, only give me packets that have this fin flag set to 1. And you can do that, of course, with Wireshark. You can say, you know, go in here and say, filter out, you know, apply as a filter, selected. So right there, it set it. So it's only going to give me, I didn't actually, we're set to 0 in this case. So that's most packets. Sorry, I should have done 1. Do 1, and then just those. And so, yeah, you kind of play with it with Wireshark. I mean, if you don't need a script, if you're just diagnosing, then, you know, Wireshark is fine. But if you're planning on doing something like automated, then yeah, you kind of figure out in Wireshark and then run in actual tshark as a script.
If you're sniffing packets and you're looking at them, if they're not encrypted, you can use the captured data and that kind of stuff. But most stuff is HTTPS, it's encrypted.
Yeah,
And
that,
you can use Wireshark for doing kind of packet sniffing and talk a little bit. Stuff, trying to see any data you can get out of it.
that's a very good point. Yes. So this is, you know, maybe emphasis for why you should make sure you're using HTTPS is, yeah, if it's set to HTTP, you know, should we try? Curl. This is different history. Okay, curl netlab.ua.edu. So sure enough, we can see it. So if you were sitting here, I mean, you could see this, it's not encrypted. I could see what your payload is, you know, what this responded back. Mind you, for a wired network, you have to be inline. You have to be running through the cable. So wired, you don't have to be worried as much, but you actually do the very same thing with wireless. And then anyone is sending out wirelessly, and I could recover that. And if it's not encrypted, if it's just using HTTP, then I could actually look at, you know, find out what you're sending back and forth.
I usually have a wireless part that supports packet sniffing, is not all of it, but certain ones like work.
Yeah. That's a big source of research for us. We do a lot of interesting stuff with that. Of once you have this device that can sniff arbitrary Wi-Fi packets, and you can also inject them, and you can do lots of interesting and fun things with it. Okay, so that's it for the tools. We got 5 minutes left. What do you guys want to talk about? I'm just kidding. Any questions for me about these tools? I hope this was helpful. This is more just an overview of what, you know, things are capable of. Of course, you're gonna have to go search and learn these things yourself. Yeah, any questions? Anything you want to see? Pair. Oh yes, that's right. Okay, curl pair. Is that how you spell parrot?
Yeah.
Dot live. That's right. That's really cool. I remember that. That's some good trickery. So what's it doing? Yeah, it's sending the, you know, control characters in a certain way. That's awesome. That's a great way to leave off. I can't top that. Everyone, get out of here.
We have achieved.
Yes. Okay. Anything else from people online, Dr. Mengelson?
I think that's great. Thanks.
Okay. I'll see you all later.
Okay. See ya.
Take my networking class.
Yeah.